This is a pretty neat integration question, mainly. Two integrations to look at, both of which look pretty complicated from first glance, but we're going to be helped along the way by certain results. So let's take a look at part A, which is to differentiate this function here. Just going to write it in index form to start with. And because I'm differentiating ln, I can use the chain rule. It's going to become 1 over u plus, and I'm going to put back in root form, u squared minus 1. Just like if you differentiate ln x, you get 1 over x. But now we use the chain rule and we differentiate the inside as well and times by that. So it's going to be 1 plus a half u squared minus 1 to the minus a half. Bring the half down, lower the power. But the inside again is a function of u, so we have to use a chain rule on this to give 2u. Note that half and the 2 are going to cancel. Going to write this as a single fraction. This is where we're headed. It doesn't look like that at the moment, but I'm going to get 1 plus u over the square root of u squared minus 1 all over u plus the square root of u squared minus 1. And somehow we have to cancel this down. There's two options now. You can either, I think, well, no, there's not. You've got to be careful, really. It might be tempting to times through by root u squared minus 1. Um, would that work? I don't want to do that. I think a good shout is to put it over a common denominator. So it's going to become root u squared minus 1 plus u over root u squared minus 1. I definitely didn't want to multiply by this denominator because this is looking a lot better now, believe it or not. So all I've done is write that 1 as root u squared minus 1 over root u squared minus 1 and then added the two together to give this term. And it's okay now actually to realize that you can basically just cancel this out with this, which will leave us with 1 over root u squared minus 1, and we're done. If you want a little bit more explanation for that, then I will give it. So you could have treated this as this divided by 1. Like it's like a fraction divided by a fraction. And then it would be u squared minus 1 rooted plus u over root u squared minus 1. Instead of dividing by this fraction, you can times by the reciprocal. And then it's a little bit easier to see that this is going to cancel with that. So I hope at this point you're happy with that. So we're asked to prove that result. We've proved it, and now we can use it and the substitution x plus 3 equals 1 over t to find this integral. So I'm just going to bring it down. It's worth just bearing it in mind because that's kind of where we're headed. What we're going to do is integrate something that looks a bit like this to get ln of something, I think. Right, the substitution. Let's x plus 3 equal, it's going to be t to the minus 1. So x is going to be t to the minus 1 minus 3, and dx by dt is therefore going to be minus t to the minus 2. This dx is going to change to dx by dt times dt using the chain rule. So we can bring this together now, and the integral is going to equal 1 over, now I've got x plus 3, which I can just replace by t to the minus 1, and then there's 2x plus 7. There's a couple ways I can go about this. I can either just substitute in for x, or because I got x plus 3 over here, I can sort of figure it out. It's going to be that 2x plus 6 is equal to 2t to the minus 1, and therefore 2x plus 7 is going to be 2t to the minus 1 plus 1, which I can write in here. Now I have to times by minus t to the minus 2, and of course still have to integrate with respect to t. Next step, I'm going to bring the minus out of the integral. I don't want it, messing about with it. Just get it out, just like you would a constant, and times, or get the t to the minus 2 to the top. Now remember, we're trying to head towards this, and we've also, we've got this is essentially a fraction within a fraction. So what I'm going to do now is I'm going to times the top by t squared and the bottom by t squared, because that will do two things. It will first of all make this equal to 1, and it will help simplify the bottom because I'll end up with a t there. It's still not quite looking how I want it. There's a single root here, so I'm going to need to bring that t inside the root. I can write t as root t squared for the purposes of this, so I can combine it. And then basically that will mean that I'm doing root t squared times 2t to the minus 1 plus 1. And I can bring these two together because root AB is root A root B. So I'm going this way, sorry. And that's going to give me root 2t plus t squared, because I've times the 2t to the minus 1 by t squared within the root, and the 1 by t squared within the root. We're not far off. It's still easy to get stuck at this point because we want u squared minus 1, and we've got 2t plus t. How can we deal with that? We've got a t and a t. Well, what we need to realize, is to complete the square. So if you complete the square, it's going to be t plus 1 all squared. Now this would give me t squared plus 2t plus 1, so I need to then minus a 1. And suddenly we go from like this to this. This is really good now because I can use the result from A with u equaling t plus 1. Sorry, that didn't quite go on the screen. Okay. So I've still got that minus, and then it's going to be ln, and all I do is replace all my u's by t plus 1. So it's going to be ln t plus 1, and then plus root, remember it was u, so it's now u squared rather, so it's t plus 1 squared minus 1. Sorry, that's within the root as well, and I'm adding c. Okay, we're not done because that is the answer in terms of t, but remember we had this substitution. X plus 3 was equal to 1 over t, which means that t is equal to 1 over x plus 3. We also have a t plus 1 in there, so it's probably worth figuring this out. T plus 1 is going to be 1 over x plus 3 plus x plus 3 over x plus 3, which is x plus 4 over x plus 3. And we're in good shape now. So we're going to get minus ln x plus 4 over x plus 3 plus the square root of x plus 4 over x plus 3 squared minus 1 plus c. I think it's okay to leave it like this. There is an advantage in doing one extra step, however, which I'm now going to do, and that is to simplify this one a little bit. Bring it under one single fraction. So this would, forget the roots, this would be x plus 4 all squared minus x plus 3 all squared over x plus 3 all squared. So I've written the 1 as x plus 3 all squared divided by x plus 3 all squared, and then I've combined them into a single under a common denominator. I've also obviously separated this into x plus 4 all squared divided by x plus 3 all squared. Now, this is a difference of two squares. So if you have a squared minus b squared, then it's a plus b times a minus b. So it's the same idea here, and I can add these two together to give me 2x plus 7, and I can times it by these two subtracted, which is just 1, and I get 2x plus 7 as my answer. And I still need to divide by x plus 3 all squared. But finally, my answer then is going to be minus ln x plus 4 over x plus 3 plus this thing square rooted, which is going to be root 2x plus 7, and I can actually square root the x plus 3 to leave me this. And that is, I'd say, a fully simplified answer, a little bit neater than leaving it like this, and it will be easy to deal with later on. I think you could leave it, even if you didn't combine these together and you'd left this is 1 over x plus 3 plus 1. That's okay. It's just going to be harder to deal with later on. So that's our answer to this integral. That's two parts of this question done. We've got D coming up, which looks pretty monstrous, doesn't it? We've got an intermediate little question, almost like a slight bit of calm before the storm, I'd say. Can we express this in partial fractions? So it's going to be equivalent to 1 over, we need to factorize it, so 2x and x. And the only options then really are, okay, 1 and 21, but that's going to make it far too big. So 3 and 7 or 7 and 3. And if we go with 7 and 3, then we'd get 6x and we'd get 7x. So that will work. And they're all going to be positive. For partial fractions, we're then going to separate into a over 2x plus 7 plus b over x plus 3. Multiplied through by this quadratic, 1 is going to be equivalent to a x plus 3 plus b 2x plus 7. Let's substitute some values in. X equals minus 3 will give that 1 is equal to minus 6 plus 7, that's b. So we've managed to get b. Well, x is equal to minus 7 over 2 will give 1 is equal to, now this is minus 3.5, so we'll be left with minus a half a, and this will disappear, so a is going to equal minus 2. And therefore, overall, 1 over 2x squared plus 13x plus 21 is identical to 1 over x plus 3. I'm going to write that one first because it's positive, minus 2 over 2x plus 7. Okay, on to the last part, which is to find this integral here, including limits. But you can see we're going to get a really neat answer at the end. Okay, let's try and get there. So I might put the limits back in a minute. I just kind of want to leave them out for the moment and figure out what's going on. So the first thing is, look, we have this 2x squared plus 13x plus 21. So I'm going to write that as a fraction by itself, and then I'm going to times it by 1 over 2x plus 7. Note this was in part B, so perhaps that's going to come back into play. Now I can write this using I can use partial fractions essentially, so I'm going to get 1 over x plus 3. Okay, from here, and I'm going to times that by this. and I'm going to separate it into that integral by itself. And then the second part, I'm going to be minusing 1 over 2x plus 7. So it's actually 2 over 2x plus 7. And then still also timesing that by 1 over root 2x plus 7. So I hope that first step is clear. I've split it into partial fractions and I've then split it into two integrals. Okay, now there's good news, and that is we've already dealt with this integral. So I think I'll just put the limits in because I can deal with it directly. Now maybe I call this one star 1. I call this one star 2. So star 1 is going to be the result we had before, minus ln x plus 4 over x plus 3. This was the end of part B. And then it was plus 2x plus 7. Oh, sorry, this was rooted over x plus 3. And this is all got a ln. Sorry, I don't want to use two square brackets, do I? But it was ln of all of this. Oh, I don't think I need a bracket there. And because I've simplified this down as much as possible, it's a little bit easier to deal with, okay? Like I said, if you didn't, you can still get there. It's just easier to make mistakes. So I'll get minus ln. Now I'm going to substitute that 9 in. So I'm going to get 13 over 12 plus, it's going to be 18 plus 7, which is 25, square rooted 5 over 12. And then I'm going to minus ln 5 over 4 plus, and I put 1 in, I'll get root 9, which is 3 over 4. So I will get ln of 8 over 4, which is ln 2. And I'm going to minus ln of 18 over 12. 18 over 12, 6 goes into both of these. So actually 18 over 12 is in fact 3 over 2. Which is the same as ln 2 over 3 over 2. Which is the same as ln 2 times 2 over 3, which is ln 4 over 3. And we've got a pretty neat answer for this part of the question. To be fair, I think that's the hardest part, making sure you just substitute really carefully, okay? Because if we've done part B, we're okay. Of course, if you haven't done part B, you're in trouble. Make sure you understand that. Then star 2. Okay, remember I'm minusing it, but let's not worry about that at the moment. It's going to be the integral of 2. I can bring that 2 out, 9, 1, and then it's going to be 1 over 2x plus 7 times root 2x plus 7. I can actually bring these together because this is just 2x plus 7 to the power of a half. So I can add the powers. It's going to be 1 over 2x plus 7 to the 3 over 2, or 2x plus 7 to the minus 3 over 2. And this is much nicer to deal with than that part B one, where we had to complete the square. So I'm gonna um, first thing is raise the power by 1 to give minus a half, divide by that new power, which is going to be minus 2, and then I'm also going to divide through by 2, like the opposite of when you differentiate this, so it's going to be times a half. If you're unsure about this kind of integral, then just differentiate it back. I would times by minus a half, which would cancel with that minus 2. I would lower the power by 1 to give me minus 3 over 2, and I would times through by the 2 using the chain rule, which would cancel with that half. So it definitely works, and this will cancel. So I'm going to get minus 2 lots of 25 to the minus a half minus 2 lots of 9 to the minus a half. And maybe I should have written that as square roots to make life a little bit easier, but I'm going to get 2, because I've got this will become positive, 2 over root 9 minus 2 over root 5, which is 2/3. Sorry, it was root 20. What was this? This should have been root 25, sorry. Which I can put over a common denominator, so 10, no, not, yeah, 10 minus 6 over 15, or 4 over 15. And we can breathe a little sigh of relief. We're basically done. So the integral from 1 to 9 of 1 over 2x squared plus 13x plus 21 multiplied by root 2x plus 7 with respect to x is equal to ln 4 over 3 minus my second integral 4 over 15. That's pretty cool. And a good challenge, but a rewarding end, I'd say. Done this whole question, and we've written it. Yeah, it just said to leave R and S as rational numbers, which we've done. So all is good.